Okay, good afternoon, everybody. Welcome to the Green Life Industry Australia's Introduction to Smart Farming webinar. We have some attendees who look like they're still logging in, but we might get started. All right, well, this Introduction to Smart Farming webinar is part of the project Digital Remote Monitoring to Improve Horticulture Environmental Performance. It is a Hort Innovation facilitated project in partnership with Applied Horticultural Research, Hitachi, Freshcare, Growcom, Ausveg and the Australian Banana Growers Council, funded under the National Landcare and Hort Innovations. Sorry, the National Landcare Project and Hort Innovations. Today we are presenting an introduction to what is smart farming and how this project is incorporating smart farming technologies into production nurseries. I'm joined here today by Barry Naylor, who is or was the original project officer who helped set up the project and is now the GIA Queensland Plant Protection Officer. Barry is going to talk us through some of the aspects of the project and outline some examples of how smart farming technologies can help in the real world decision-making process. So the intent of this project is based on improving the environmental sustainability of plant production within the Great Barrier Reef Marine Park catchment. However, the outcomes of the project will be relevant for all of the nursery industry Australia-wide. So I suppose from here on, we just get started. And of course, the main question is, what is smart farming? So smart farming techniques and technologies have actually been used in the nursery industry and other industries for decades, but with various levels of monitoring and control capabilities. Essentially, smart farming is a form of production agriculture, Right, so I've just been informed that I had not shared my screen fully. And so let me go back and just put this screen up. So this is the introduction to smart farming, digital remote monitoring to improve horticulture environment performance as the GIA component of it. Smart farming, as I said, the techniques and technologies have been used for many years in various industries, but the level of monitoring and control capabilities has changed dramatically. Essentially, smart farming is a form of precision agriculture or precision horticulture, where growers use smart sensors connected via communication technologies to remotely monitor and control their production processes. Practically, what this means is a series of interconnected digital sensors that monitor various production parameters around the nursery that feed data back to a central computer or dashboard that will enable the manager of the nursery or the farm to see what's happening in real time around the nursery. This will allow for a proactive decision making to any issues that may arise. It improves production efficiencies and optimises labour by reducing the time needed to diagnose problems, and it improves environmental performance as all the inputs and outputs or resources are monitored in real time. So that's a very basic formal overview of what smart farming is. So the next question, of course, is why should we use smart farming? If you are currently measuring your environmental or agronomic parameters manually, or would like to reduce the time and labour spent in collecting that data and interpreting that data, or you would like to have a real-time snapshot of how your system is working at any time of the day or night, or if you just simply want to know if you're over or under watering your plants, using too much fertiliser or too much pesticides. If the answer to any of these questions or points is yes, then integrating some form of smart technologies into your management strategies is something worth considering. Instead of finding out there was a problem after the fact, so let's say your irrigation system or your fertilizer levels are way out and they start to damage your crop, then it's too late once they've been damaged. So by having real-time monitoring systems in place, that shows an issue as it's occurring and helps you to avoid crop damage, and not only avoid crop damage, but to also avoid the loss of the resources that's already been expended in that crop if you have to throw that crop away. Now, one of the benefits of modern technology is the development of all these new communication technologies that help to incorporate some of these smart farm technologies. It is becoming more cost effective and certainly a lot cheaper than it used to be. So you don't actually have to spend a lot of money or have the most complicated system and cover every aspect of your business or your production processes. Just starting with some basic sensors can prove a huge change in resource use. Monitoring irrigation system will help you adjust your irrigation scheduling and reduce water use, which will help reduce energy use, which will help reduce fertilizer losses and leaching out of the pots or containers. And as the systems will record actual production parameters, such as your water quality and fertilizer usage and so forth, it provides a baseline performance or benchmark of the environmental indicators that can be used to inform business decisions, drive good environmental stewardship, and provide evidence that your business is meeting the industry best practice management. So that's just a quick overview of what smart farming is and some benefits that can be gained. But I'm now going to hand over to Barry, who helped develop the project, and get a viewpoint of smart farming from a nursery manager's point of view, as Barry has actually owned and managed his own nurseries. So I'm going to hand over and we're going to do a chair swap instead of a share screen.
Good morning and good afternoon to you, no matter where you're coming from. My name's Barry Naylor. I'm currently, as Dave said, Plant Protection Officer in Queensland and Northern New South Wales, but for the first year of the Smart Farming Project was the Smart Farming Project Officer. So I was involved not in the instigation of the project, that was through John McDonald, our National Biosecurity Manager, but obviously I was the Project Officer for the first 12 months. So what exactly is the GIA Smart Farming Partnership? GIA has established a pilot smart farm. It is a project condition that this particular smart farm was established in the Great Barrier Reef catchment area, and like David has already mentioned and will mention throughout the duration of the project, whilst our funding made it compulsory that the pilot farm was in the Great Barrier Reef catchment area, what we learn and glean and are able to provide to the industry by way of advice, of course, will be applicable no matter what environmental circumstance you find yourself in. We had to establish a range of environmental parameters that could be measured, and we based those on Hort EMS. I mean, it would make quite good sense, I would think, seeing as we've got an environmental management system, to go through Hort and establish those things that are required to be manually measured, and where there may be some benefit in providing not only the automated recording of that information, but the perpetual recording of that information. So as David said, that it can inform decision making. So much of what we've done before with the manual measurement of it is totally reactive and not done in a timely fashion where you can adjust the business practice. The idea with smart farming is let's identify these parameters that we can measure 24/7 and give you enough information that you may be able to adjust the practices in your enterprise in real time. The series of remote sensors that we identified in a number of different areas around the enterprise are being installed at the pilot farm in conjunction with our project partner, Applied Horticultural Research. And the electronic sort of side of it, the side that is the dashboard that you've heard David mention, is our other project partner, Hitachi Vantara. And the dashboard is basically the repository of all of that, information that's coming in on the feed from those various remote sensors that enables things to be seen, I guess, in one screen snapshot. This is an overview picture of the actual Smart Farm enterprise. And I guess it's like a lot of us in our nurseries, we've got our favourite letters and or numbers to identify certain parts of it. But just to give you an idea, in this particular place, we had to identify, I guess, where the most appropriate point in the nursery was to measure certain parameters. And I'll give you an example, just one example while we've got this particular shot up. If you notice at the base of the house that's marked G, you should be able to notice on your screens a line of palm trees. And that line of palm trees heads to the right along the bottoms of E, D, C, B, all the way to the bottom corner of A. And then you'll notice that there has been the installation of a drainage sump. That was something that the enterprise in question was thinking about installing, and that was hastened somewhat with the opportunity to put that sump in there to collect the water that was running down the side of the property before entering the dam. Because in this particular instance, the water not only goes into the dam, but in the case of dam overflow, flows back past that sump as well. So we've put sensors there, which would be obvious in this case to measure both the water used within the enterprise that is going back to the recycling pond, but perhaps in more extreme events would enable us to monitor what's going on by way of final water leaving the enterprise, so that we know what our contribution is to the environment, and hopefully that's a positive, or shall we say not a negative contribution. Okay, so what are we measuring at the pilot Smart Farm production nursery? One of the main things is we've established a state-of-the-art weather station to measure all of the standard temperature, humidity, solar radiation, wind speed and direction, things like rainfall, and many other things that can be determined by calculation from the data that comes from the weather station, like evapotranspiration. A point to point out, and this will be raised elsewhere by David, is that this is installed in the microclimate. So a lot of us in our nurseries will use things like our BOM for our weather information. What installing the weather station in the microclimate will prove to us, I suppose, is what is the difference between the temperature that BOM says that we have in our particular enterprise to what we actually have in our enterprise. And obviously that would apply to humidity and many of the other parameters that the weather station will give us data on. In the case of source water, so in this case there's a single pond down at the back of the nursery. We're measuring pH, EC, temperature and redox. We have the capacity to measure the drainage water, as I said, in that sump down the side. There's probably a 2-point measurement that looks like it's going to happen because things have changed since I was involved originally. But obviously you are required to measure these things within, so anyone that's in EcoHort is required to measure the pH, EC of their water in this instance. And the idea is, wouldn't you like to know what the difference is between what you're using on the enterprise, on your crops? Would you like to know what's coming back by way of effluent recycled water? And then where we mention outflow, that's obviously what contribution are we making in the quality of the last point of water that we have before exiting the property. One of the, so I guess the best parts about being involved in projects like this is you can start to stretch your imagination, and you'll see we've included some early warning pest monitoring cameras in the particular deployment. What the idea there is that we are able to have some cameras on some sticky traps, and perhaps get prompted to hasten our crop monitoring in a particular area if we notice an issue outside of our normal crop monitoring times. Residual chlorine is obviously a matter that we like all of our enterprises to measure, to know what they've got by way of parts per million of residual chlorine. If chlorine is their given disinfestation method, we are looking at automating the measurement of that. So 24/7, you're getting a measure of what parts per million you have residual by way of chlorine in your irrigation water. When it comes to some of the other parameters that we would like enterprises to use for production nurseries using nitrate, phosphate, sulfate and iron and others, they prove somewhat problematic and sometimes too expensive to be monitored by pure live 24/7 monitoring. So what we decided we would do is install a desktop photometer. What this enables this particular enterprise to do is to take samples at given times and take those samples up to the office, and this desktop photometer is able to give them a measurement of nitrate, phosphate, sulfate, iron and some others, and then the data is actually linked into the dashboard in the same manner that would be from automated sensors. We've got down here that we're going to continue the work done with weight-based irrigation controller. For those of you that don't realise, David Hunt was the originator of all of the research that we've done in this space, and has conducted projects on behalf of John McDonnell for many years here, and he's the right man to be continuing that particular research on the smart farm. And lastly, we've mentioned leachate quantity and quality. So again, instead of requiring our production nurseries to manually measure what their leachate is at a particular time, which can be a somewhat cumbersome process, we've been able to get onto some equipment that is able to measure both the leachate quantity and the quality and give us those readings in perpetual fashion on the dashboard. I think that's a particularly exciting addition to the suite of information that we're going to be able to gather. I will hand over to David Hunt.
Thanks, Barry. So as mentioned, there are various sensors installed around the nursery in locations that give us the best reference point for the crop. Again, as Barry stated, the weather station is set up in the shade house under shade cloth instead of out by the dam. This is done on purpose because we want to know what the microclimate of the crop is. These are the key conditions that directly influence the plant growth. This is the same basically as monitoring and testing PHEC and nitrate levels in dam water, or testing container leachate for fertiliser content. These are the parameters and resources that tell us how the production system is working and if the plant is growing in an optimal growing environment. Pardon me. How complicated this sensor network is will depend on a couple of things. How much the manager wants to be involved, how much does he want to monitor? Does he want to monitor everything, he or she, monitor everything, every process that's in the nursery? But there are some basic requirements, as Barry has stated, for reporting, as outlined in the industry best management practices guidelines, as well as the Eco-Hort guidelines. And this is a good place to start if you're thinking about getting into smart farming. You can go to the nurseryproductionfms.com.au website. There is a whole swag of technical articles and information there. There is also a preview to the Eco-Hort guidelines. There's also a lot of other relevant resources and information on plant production standards. So if you're interested, that's a good place to start, and that'll give you those basic parameters that you should start looking at. So once you've got all this sorted out, it's like, how do you collate all of this information into one area? So the data from these sensors is wirelessly sent to a central control computer or dashboard that's in the office. This gives the nursery manager one point to check. So there's one screen in the office that will show all of the parameters. He doesn't have to walk around the nursery. He doesn't have to try and contact, he or she doesn't have to try and contact staff in the field to find out what's going on, or run halfway down the paddock to try and determine whether the irrigation is still working. So the dashboard, now I have to say right now, these images that I'm about to put up, they are a beta version. The dashboard is still under development. So these are a basic image of what it will look like, but this will change as we refine the whole process. It will give an overview of all the parameters around the nursery, or the sensors around the nursery, and it will alert the manager to any parameters that drift outside of a set range. So you can see along the top, there's a list of different parameters in the alert section. These will highlight if there is an issue. There'll be a nursery map showing the location of where the sensors are, and so this will show which sensors triggering, and there won't be any confusion about where in the nursery they have to go and look. Each sensor will be shown individually in a simple graph, pardon me, that allows the time period to be changed. So at the moment, they're on a 7-day time period. You'll be able to put it on a daytime, a single day, to have a look at how that measurement's changed over a period of the 24 hours, or you can extend that out to several weeks so you can see the trends that have happened over the period of time. So this, you can identify any points of concern. So if there is a point where it's your pH is excessively high, you might want to have a look why. Because if you do irrigate with high pH, it will be some time before the plants start to show any damage, and you want to try and get onto that before the damage becomes too extensive. In anticipation of the monitoring cameras, we're also hoping that these will be displayed on the dashboard. So at a single glance, you'll be able to have a look at what's being displayed on your cameras, what your sensors are doing, and so forth. There will be also sensors not only in the dam to monitor the dam water quality and temperature in case there's some sort of increase in nitrogen or algal bloom, but there'll also be sensors, as Barry has said, in the final discharge point of the dam, so we know what quality of water is being released from the property. This will become more important as we have to start and record or report on water quality outflows, especially in heavy rain events. So as the project continues, the dashboard will be refined. So by the time we have a field day towards the end of this year, we should have a dashboard that's fully operational and be easy to see. So that's basically just another quick overview of the sensors and the dashboard and how this is going to be displayed. I'm going to hand back over to Barry now, so he can actually talk us through how this information is going to be used in a real world management decision-making process. So I'll hand back over to Barry.
Thank you, David. So what we hope to do with this next particular section, as David has outlined, is just give you a few examples of what would smart farming actually, what would the information that is presented on the dashboard do to you in a practical sense? What information would it provide you, and what would you be able to do with that? So let's use a couple of examples that we've got here. So say the smart farming, you employ this particular, both the sensors and the dashboard in your particular enterprise, and up on the screen it shows that you've got a leachate percentage of 30%. So those of you that will remember from so those of you that are familiar with our best management practice guidelines will know that we aim for 12%. So we've got down there, that we're trying to hit 12 to 15 in the change management section. You just simply look at it and go, oh, look, it's 30%. You put the equipment in, it first tells you that your leachate is at, you're running at 30% volume of leachate out of the bottom of your pot. And we've identified that our industry target is around that 12%. So you immediately know I'm just going to have to wind back the irrigation and continue to slowly wind back until you hit that sweet spot of 12, and as we're saying there, 15%, in that 12 to 15% range, with 12 being the ultimate target. Why would you do that? Well, it's reduced water use for a start. That makes sense. It's reduced pumping costs. That doesn't take much to work that out. But what we do when we're overwatering is, of course, we create problems for ourselves that might lead to extra disease. Certainly if you're watering where your leachate percentage is 30%, you're definitely overwatering your stock. So if you got your leachate percentage down to that 12% mark, you'd have less disease, you'd use less pesticide, and there'd be the flow-on effect, of course, is less negative impact on the environment. Most importantly, if you can get your leachate into that 12%, leaving the bottom of the container, your fertilizer is staying in the container doing its job, which is helping the plant grow, and it's not ending up flooding out the bottom of the pot, flooding down the drain, and contributing, obviously, in a negative way to the environment. That just makes good sense, good business sense, and should hopefully increase your margins. Okay, in example 2, the smart farming data comes up on the screen, and it says the nitrate reading in our source water is 100 parts per million, but more importantly, that's a lot more than it usually is. It might usually be 40 or 50 parts per million, but for some reason the data on the dashboard is showing that you've got 100 parts per million. So the first thing you can do is look at the irrigation timings and the leachate percentages for any anomalies. See what other data is showing that might be able to make a contribution to why we're getting this sudden spike in our nitrate up to 100 parts per million. You can then also check the fertigation regime that's been implemented in the past week, and again, you're just comparing that to the background nitrate readings. When I put this particular example together, we used an example like this. You might find there's a complete section of recently potted plants and it's receiving irrigation at the mature plant rate. That's because Mark said that he was going to do that before he left on holidays, and suddenly your dashboard is saying that you've got this nitrate reading, and you realise that before Mark went, he was going to adjust the irrigation in shade house A to represent the new recently potted plants rather than the crop that was in there 2 weeks ago, which was mature age, but he didn't get around to it, and you've had to suddenly have to readjust the scheduling of your irrigation. You also find, I suppose, in the process that the fertigation program was not adjusted to accommodate the background nitrate readings from the week or weeks prior, and you find you also have to adjust down because you've got enough data to know, well, hang on, let's not put our fertigation up at the higher level because right now we're running fairly high levels in our background water. As you can see, and just imagining this in your own enterprises, having that information at your fingertips means that you can be proactive in the management of the business far more than you could if you're still just doing manually recording as we are at the moment. So what are the benefits of bringing all of those things back into line when you've had that reading of 100 parts per million? Well, we've wound the irrigation back to match the crop size. So we've reduced our water use, our pumping cost. We've reduced the labour of people finding faults. We've got again, as we've mentioned with the other example, an optimum fertiliser delivery, to produce those strong, healthy growth. In other words, if you've got a nice high level of background nitrate, would you wind down the fertigation so that you're actually matching the needs of the plants to produce strong, healthy growth? No, not overly soft growth. Less wasted fertiliser, as we said with the other example, less negative impact on the environment. You want to manage, I suppose, the nitrate level in that source so that you're using it at its optimum. And of course, the biggest thing is to think about what all of the cumulative effect of all of these minor incremental things have on improved profitability. I cannot stress the amount of, someone who's worked in this industry for nearly 40 years, the chronic overwatering that we have still in this industry particularly in our state, but it's the same nationwide. This is one area where we can still do a whole lot better than what we do now. And I would like to think that smart farming and those that adopt, these sorts of technologies might be alarmed at what they're going to learn and what they're going to save by using the information to its best use. Okay, so an example 3 is that we got our fancy new cameras that are focused on our sticky traps. Now, if you're an enterprise that uses a crop monitoring program or regime in your business, you might say that we normally do that once a week. But the idea with having this camera on the sticky trap means that for all time, we are able to see whether there is anything in this particular crop on this particular sticky trap with this particular camera. If you suddenly notice that one of your sticky traps is looking like it's got a lot of activity on it, you can take the opportunity to zoom in with that particular camera and see that, hello, something down there, it's Thursday. You normally monitor on a Monday. It would mean that you could send in your monitoring team ahead of their normal scheduled crop monitoring activity, just to evaluate populations and to make an assessment about what the next course of action is in your business. If you knew this in between times of when you would ordinarily measure things, and if you knew it in a perpetual 24/7 fashion, early detection allows you, in this case, to deploy biological agents in a timely fashion. If you found that you had aphids, it might just mean that you're able to go and put your predatory biological agent out there in a timely fashion and not actually need to apply chemical at all. Zero pesticide use is a good thing if it's possible. Zero negative impact on the environment. The crop remains obviously in A1 quality because we've got onto it, we've nipped it in the bud before it's got out of control, and all of those things lead to improved profitability. So we would like to think that these are just a few examples of, and I'm sure you can think of some in your own enterprise, that if you had this kind of information available to you every minute of the day, what would be possible to change in your business so that negative impacts are reduced and profitability is increased. I'd encourage you to keep looking at it. Thank you, David.
All right, so thanks, Barry. We'll just move on to the next slide there. So those examples that Barry gives are some very common examples. I'm sure everyone will have an idea of what they can do in their own nursery with the information that they get. So the next question, of course, is where do we go to from here? We continue to collect the data and develop how this data can be incorporated into everyday operating procedures. We continue to install and test these sensors to determine their efficacy and refine how the data is displayed to reduce the amount of time needed to interpret what the data is telling us. We are going to continue developing remote monitoring links to the industry's audit management system. This is, if you're under EcoHort, part of that is to report to the, you have an audit once a year to report on how your production processes meet industry practices. So there's going to be a automated remote connection to the AMS system. So this will allow the data to be sent directly to the AMS. So this will not only reduce reporting and auditing times, but will provide a central point with all the required evidence on how the business is meeting the industry best practice. And of course, we will be doing further evaluation on a weight-based system to determine how it can be integrated into the smart farming processes and technologies. So how can you stay up to date with what's going on? Use the contact details below, my name and contact email and phone numbers there if you wish to discuss matters or require further information. You can certainly give me a call, or you can also go to the Nursery Production FMS website there, the last point on the list. As I said before, it has a variety of resources and technical information for production managers. It also has a preview to the EcoHort guidelines and gives you a basic overview. Some of those resources are very valuable. So that's pretty much our presentation for smart farming. Thank you for attending the smart farming process, and a big thank you to Barry for all his work on the project and this webinar. Now, before I actually start asking for questions, I thought I'd preempt a question and talk about how much will it cost to install smart farming technologies. To use a very old phrase, how long's a piece of string? The technologies involved can be very, very inexpensive to install. So you might put in a couple of sensors. It could cost anywhere from $5,000 to $50,000. It depends on the extent in which you want to monitor your system, the size of your business, the condition of your business. I do want to also stress that installing smart farming technologies and sensors is not necessarily going to improve the efficiency of processes or an irrigation system if that system doesn't meet industry best practice. Installing sensors will help you to refine your management processes, but it won't actually improve the efficiency of an irrigation system or that 30-year-old pump that might be working down in the back shed. There are different levels of technology. The best thing to do is, as I said earlier on, is to start basic, look at what parameters you really want to look at, pH, EC, maybe how much is being leached, whether or not your fertilizer is being leached. And as Barry said, some of these sensors can be extremely expensive. So that's where you start to get up into that realm of $40,000 or $50,000. In Europe, where they have highly controlled protected cropping, some of these greenhouses would cost $200,000, $300,000. So you don't need to start by putting in absolutely everything, the biggest, the best of everything, but at least some basic sensors or some basic monitoring techniques will help you to refine your resources. Now, somebody has sent through a question here. What about sensors that measure soil moisture? Surely putting one in each crop of plants is easier, faster, and more scalable than weight-based water measurement. Okay, well, let's talk about soil moisture sensors. Soil moisture sensors are a very useful tool. They can tell you a lot of things. They can talk to you about the wetting front as it moves through the soil or media profile. They can help you to refine your irrigation scheduling. And they certainly do have a place in the world of precision agriculture. And even to a point in some, let's say, long-term landscape tree producing nurseries or flower farms that grow in the ground and that sort of thing. When you're talking about small containers, and we're talking either plugs that can be small little plugs, 140 ml pots, 200 ml pots, installing a soil moisture sensor in some of these containers, the containers aren't big enough, really. Not only that, is that the growing media tends to have a higher airfield porosity, and so the soil moisture sensor would need to be calibrated for each specific growing media. By all means, using an insertion soil moisture meter, which is normally just 2 prongs that you can stick straight in, it'll give you a basic moisture reading and an EC reading. And having done some work with turf farmers in the past, I've had a couple of them use these things, and as I say to them, you don't necessarily have to laboratory calibrate the device to your exact system. You intuitively get a feel for these things. So if you do use an insertion soil moisture sensor and you use it regularly, you start to get a feel for what the numbers should be. And if those numbers start to drastically change from what they have been, then obviously there's a problem. If you want to go down the full path of having a fully installed, calibrated soil moisture sensor system, then you have to consider how long is that sensor going to be in the crop for? What about root growth? In the case of containers, if 140 ml container is quite small, they will be potted out within a matter of weeks. That means you're constantly removing and reinstalling. So there's all those sort of issues.
And they are part of the project.
They are part of the project indeed. We are certainly looking at that sort of stuff. We actually found with the weight-based measurement is that you can actually obtain more information from using weight-based. So once it's calibrated to the pot, to the indicator plant that you're using, you can actually trigger a container capacity test. So it will actually identify what the maximum water holding capacity of that container is. As that dries out, the weight drops. So you can then identify what your trigger points are, your maximum or irrigation trigger, your minimum irrigation trigger. You can also monitor vegetative plant growth through the increase in weight. That was part of this system, is that it has an algorithm in it where it would automatically adjust for that. But I'm not going to get into that because that is not the primary part of smart farms. But I think that pretty much covers off on that question. I don't see how a sensor's calibrated so you can be confident with the data. Good question. Of course, calibration, sensors need to be calibrated. They need to be cleaned. You put sensors into dirty water, whether it's clean water, you'll get a film develop over those sensors, and that film will actually interfere with the readings or change the accuracy of those readings. So you need to clean and calibrate the sensors regularly. In most cases, the calibration is very simple. You simply have two solutions of known concentrations, and you put it in and you take that reading, and then you adjust the slope of the line, or there's various other terminologies used. But once that has been calibrated, and if it's done on a regular basis, then your data will continue to show a semi-regular trend. I suppose it comes down to having a little bit of faith in the technology. If you don't trust your technology, then, without going into too much detail, if you don't trust the technology, then you need to use it for a period of time and compare that to your regular monitoring process. In the past, I used to say to people, most nursery managers use their finger to test moisture content, that they need to calibrate their finger to the sensor technology, or calibrate the sensor technology to their finger. So once they've done that over a period of time and they're confident that the sensors and their data is giving them the information, then they tend to start and slowly accept that these sensors are accurate. But accuracy comes down to the cleaning regime and the calibration regime. So if you don't look after your equipment, it won't necessarily be accurate. I don't know if there's any more here. Okay, what's this? Are there any smart farming sensors available for monitoring the incidence and severity of disease, similar to how you have cameras set up, blah, blah, blah? At this point in time, I don't believe there's been any sensors that have specifically targeted disease itself. I suppose I'm not too sure whether there's been any research done in, say, leaf turgidity sensors, or thickness sensors, or stomatal conductance sensors that may be correlated to disease. It's something I'm not aware of. It's certainly an idea. But at this point in time, we are only in infancy of smart farming, so how we go from there, I watch this space, that's all I can say. What are smart farming sensors available? What else do we have here? I don't know if that's all of them. I think that might be all of the questions for now. Yep. Okay, so what's this? Yes, this is being recorded. I believe there will be a recording of this on the GIA website under events and video. Okay. By the looks of it, we've answered most of the questions that were there. So if Barry hasn't got anything else to offer?
No, all I'd say about, so I'll just talk in the side here, guys, is with regard to the likelihood of being able to do, sort of photographic or sensor work on things like disease, you'll understand that we are limited by budget. So what we had to do is we had to decide how to deploy the budget in the area of sensing that would give the industry the best bang for its buck, i.e. which ones would be most likely to be adopted, and at the same time give them information that could help them in their business. So we had to stick to, I guess, what you'd call established technologies rather than emerging technologies, albeit that things like the chlorine, residual chlorine is like our own little, version of that, because there wasn't anything in the space that we needed to do it in a timed fashion after the time of injection. But I guess just keep your mind on the fact that we've had to make a decision on in relation to the budget, so that decisions on what sensors we would deploy and or what things we would measure were based on industry best bang for buck. So please understand.
Okay. The other thing too, with I've just realised, with using sensors to try and identify disease, the world of disease identification, there's an actual entire career based around that. The symptoms that you see in the field can relate to a dozen different pathogens. So to be able to say, is there a technology that can identify the different pathogens of different diseases, whether it be a bacterial or a fungal disease, you're now getting into the realm of laboratory analysis. And at this point in time, I don't know of any portable labs that you could use to do that. And if there is one out there, I can guarantee you that your average person probably can't afford it. That's about all I have to say in regards to that one at the moment. Unfortunately, I think that's pretty much it for us, and I'm happy to wrap that up. Like I said, if there are any further questions or anybody is interested in being involved, then by all means send me an email on the details at d.hunt@greenlifeindustries.com.au, and I'll answer any questions that I can. And from there on, I will let you know about any up and coming events and a field day. Also keep an eye open for the GIA e-newsletter. In there are regular tips and facts on smart farming and nursery production. So also that's where we will advertise our next field or our field day. But for now, thank you all for attending. Thank you, Barry, for assisting, and I hope you all have a wonderful day. Thank you and farewell.